So today we will look at how to deal with mathematical operations, expressions in Python. So basically using Python as a calculator. We will also plot a few graphs, which in my opinion is something very exciting. And at the end of the class, a video recording of this session will be shared in my YouTube channel, and this notebook will be deposited to my GitHub repository. Okay, so, just for completeness, these are the basic mathematical operators in Python. You're already familiar with the first three, addition, subtraction, and multiplication. And the fourth, this one, is for exponents or powers. So if you want to say 3 to the power 4, you just say 3, star 4. Then, okay, normal division is okay as well. We know that. But this, I'm sure, will be a little strange to some people. This is floor division, and what floor division means is that, say, if you're dividing, say, 4 over 3, then you know that the answer you get has two parts. It has a whole number part and a decimal part. So floor division only returns the whole number part. It discards the fractional part. Then this is modulo division, which I'm sure, again, most people, some people would understand what modulo means. Modulo means here you're still dividing, but you have no interest in the quotient. In the whole number part, basically. All you want is the remainder. So, for example, if you say 7 percentage 5, means here we are only interested in the remainder, which is 2. So let's see a couple of examples. So, for example, this expression here is 6 squared minus 3. Okay, let me connect that first. So you see. Okay, initializing. So 6 squared minus 3, this is how you would write it. And yeah, run anyway. So you see, so it gives you the answer. Now let's say here we want to evaluate this expression. Normal division is just 50 minus 3 times 9 over 4. This is simple. It gives us 5.75. Well, let's say in this case, we are only interested in the whole number. We don't care about the fractional part. Then we don't use a single forward slash. We use the single backward slash. We use the double backward slash. And so you see, now you can see that this is discarded. And all of these have use in programming, as you'll see, maybe not in the session, but if you were to to look for examples online, you see that they have their own application. Then let's say in this case here, here we wanted only the whole number part. Now in this case, let's say we want only the remainder. See, this is what you do easily, and you can see the proof here. So that is it. So this is very clear. Now let's go to variables and expressions. Make this a little more challenging. Okay. I'm sure you have already come across this. We have dealt with variables in some way or informally. Okay, so when you say a variable in programming, a variable is just it's just I'll say it's just a container for storing data. Okay, and I would reckon, I would liken that to an address. Okay, an addressing system. So you're just telling Python that this is the address, quote unquote, for this data. So if you were to, let's say you were to store the value 5 in a variable named A, so you're telling Python that, okay, there is a location in memory or in the current workspace that I want you to name A and store the value 5. So whenever you save A, Python will just go to that location, will just fetch the name basically and retrieve the value that has been stored in it. Okay, you can use any name. Okay, but there are a couple of reserved keywords in Python that you cannot use. Okay, like and, for, print, break, while, if, yield, return. There's a host of them, and you could easily find them here. Okay, and if you use these, there'll be an error. In fact, you would definitely know, because, for example, let's say you write print. You see, it's a different color here. Okay, the color actually depends on the platform you're using, but you'll notice that it's not the normal black ink. Okay, it's maybe it could be mauve, it could be blue, it could be like here gold. Okay, and as I said, you can use any name, but it makes a lot of sense to use names that are meaningful. Okay, you want to use a meaningful name because you want to understand your code when you read it, or you want someone else to understand your code when they read it. Okay, so for example, if you were to find, you were writing a code to find the roots of a quadratic equation. Okay, quadratic equation has 2 roots, basically. So it's easier. Okay, it's easily understood if you write, if you name the roots root 1 and root 2. So easily someone reads, they know, oh, this is the roots, okay? But if you were to name them Chelsea and Arsenal, then you would need to explain, for someone to understand, even yourself, because sometimes when you write a code and come back to it after 2 weeks or 3 months, believe me, you'll be wondering if you wrote that code, okay? Because it will look very new to you. So you want to always use meaningful names, okay? And you can you can use, say, multiple words, okay? And the rule, well, it's not really binding, but it's sort of an accepted norm now. Okay, so if you are using a name that has multiple words, it makes sense. Well, the convention, the accepted convention is you separate those names or those words with underscore. So, for example, my first var. So this is easily understood. So someone straight away reads it, they know it's the first variable. See, good. So now let's see how this works. So now let's say we want to assign the value 7 to a variable called my length. So you see, so you write it, you run it. This has already been saved in the current workspace. So if at some point I try to retrieve my length, automatically Python just goes there and fetch the value that is there. So okay, so my breadth, this is it. But one thing you have to note is that you can only store one set of data in a variable at a time. So for example, okay, let me just see. So let's say I'd say A is equal to 7. Okay, so let's print A in this case. Good. Now A is 7. Okay. So now let's say at some point I say, okay, now A is no longer 7, A is 8. Okay. Run this. And now let me print A. Now you see it's 8 because, you know, what Python does is like it overwrites the original value, because as I told you, you know, you just picture this as one small location in memory, so to put it. And so if you say A is equal to 7 initially, and later I come back and say A is equal to 8 now. So what Python does is it overwrites. So it erases the original value and replaces it with the most recent one. Okay? So just so you know. So now let's say, okay, so you see, so we have defined two variables, my length and my breadth. And now let's say we want to use these to calculate some area. Okay? And we want to store the value, the answer, in a new variable called my area. So you see, so instead of just say 7 times 4, no, we just bring the variables that we defined earlier. We calculate this, and then here we have my area. Now, good, okay. So, and once this is there, it's there forever. Well, until we'll delete it manually or we close the session. Okay, so see, so now if I were to say print my area, it will just print. So it doesn't matter where in the code I say print. So here print my area. See, to print it because this is now in memory. Okay, good. Now let's see what happens. Okay, there's some nice things to see. So now if you want to know the variables currently stored in the workspace, the command uses who, you know, which is convenient, right? Who. So it's like saying who is here. So if you run who, you can see, so now we have 4 variables in the current workspace. And they're listed here. Okay. But in fact, there is, you know, there's a more interesting command. Okay. Because here we don't, you know, it just lists the variables. It doesn't say what the values are or what the types are. Okay. So if you use the command whos, just add s, then see what happens. So it gives you a more complete information. So you see a table here with the variables, as you can see, alphabetically listed, their type. So this is saying all of them are integers and their actual value here. So this is super cool. Okay. And you can delete variables basically. So let's see, if we want to delete any variable here, we just use the del command. So you say del and you put the name of the variable here. You run it. Now, you know, it should be deleted from memory. Okay. But how do you know that it's deleted? You can check this anyways. You see, now if you run this whos, there's no my area any longer. Okay. And if you were to try and call my area, say use it in an operation, see what happens. You get an error. Okay. And you see here, error, name my area is not defined, because it, you know what Python is actually doing is you're saying print my area. So you're like telling Python that go into your address or wherever you keep your variables and look for this variable named my area and print it to the console. So Python goes, it doesn't find it. So that's why there's an error here. Okay. But you could, let's say you want to delete all the variables. Then there is an easy way here. You just use this command reset. Okay. But you have to be careful because reset is irreversible. Okay. So if you were to run this, so what Python does is that it tells you once deleted variables cannot be recovered, proceed yes or no. So if you don't want to proceed, you just put N and put enter. say nothing done, tells you, okay? So if we want to delete them, put yes, put enter, then they are gone, okay? So if we run who's now, you see that tells you interactive namespace is empty. Namespace is just where Python keeps or stores variables, names, and data. Okay, good. This is going well. So now let's dig a bit deeper now. Okay, so let's say we have two arbitrary variables here. A is an integer, is a negative integer, and B is a list. Okay, now let's see what we can do with these. Okay, so Python has this command called abs. Okay, abs is just used to get the absolute value of something. Absolute value means you don't care about sign. You want to discard the sign. So if we were to say abs A, meaning we want only the actual number. We don't care about the sign. So you see, because okay, I need to run this now. Good. Because, so you see, now abs A, because A is -6, but abs A, which we have saved at C, is, is signless, okay? You could also get the minimum, and this is very useful. So let's say we have this list, we want to know the minimum value, the minimum element in that, okay, list. So easily we know that 0 is the minimum. So the command here again, as you should, what I want you to know here is that the command here is just min, okay? And here max, that's also simple to understand. And this just gives us the maximum, and the maximum, as we can see here, is 8. Okay, good. Now getting a little challenging now. So okay, so now let's see Python's math module. That's one very good thing about Python is that it has lots of modules and libraries. Okay, a module is just a container of functions. So which means this is a container that has lots of functions, different functions for doing various things. Okay, and Python has an inbuilt, so this one comes with Python. You don't need to install it. Okay, and this is the container, the universal container for all mathematical functions. Okay, so and the list is really long. Okay, so here you see that I have only taken a few. Okay, and you don't need to memorize them. It's because whenever you want to use a function, all you need to know is that that function is in the math module. Okay, so any function that has to do with some mathematical operation, you can find it in the math module. So if you want a full list of those functions, you just go here. Okay, this is the official Python tutorial, so they're all listed here and described. Okay, you could do that later, and you no need to memorize. Just know that okay, this function is here. So when you need the function, then there are lots of materials online that will teach you how to use these functions. Okay, but the key thing to learn here is how to import the module, because in Python, before you can use a module or a library or or package or something, it has to be imported into the current workspace. Okay, and there are two ways to import. To import any module. Well, there are two main ways. I think there are three or so, but there are two main ways to import module. Okay, so the first way is you just say import and use the name of the module. Okay, so import math. Okay, so here when you use the syntax, before you can use any function, you have to use this syntax, math dot, then the name of the function. So if, let's say it's sine, we just say math dot sine, then we use it. Okay. So if you do not say that, you will get an error. Okay. Because you just imported, and you just, that function is appended to the math module. Okay. Then the other way is, which is the way I like and most people like, because sometimes some modules have really long names, okay, and you don't want to use long, very long, names in your code, okay, gets messy sometimes. So you say import math as M. So this M is like an alias. So you're like saying math aka M, okay, and most people just use either the first letter or just find two letters that that nicely, or 2 or 3 letters in fact, that nicely represent that module. So here we say import math as M, and so in that case, instead of using math.func, we just use m.func, because M is an alias of math. Okay, so now let's see what we can do with this. Okay, and I have grouped, well, most of the functions or methods in a math module are like grouped, so you have trigonometry, you have constants. Okay, well, you'll see them later. So let's see. So constants and angular conversion. So let's, this popular pi. We all know what pi is 22/7 or 3.14 something. So if we want to use, pi actually appears in, pi is very relevant. It appears in most expressions, multiple expressions. So if you want to use pi, you just say M, because we have imported math as M. So m.pi. Simple. So that gives you the pi value. But here we have, we just want to assign it to this variable called pi val. So if we were to print this, yes, because, and that's something to note. You need to import this first before you can run it. So it's saying name M is not defined because, we want to use M, but M has not been defined. Okay, so now we go to see pi is that, and that's simple. And you can also convert from degrees to radians, from radians to degrees. And again, something you need to know, in fact, that's really easy. Okay, so now let's say you have imported the module. Okay, so if you want to know the functions or methods in that module, just put M here, because the alias we use is M dot, and you can see a list of all the functions, the inbuilt functions in that module here, so you can see. So even if you're not too sure, just have a look straight away. It will jog your memory that, oh, good, yeah, this is it. So okay, so let's go now. Okay, okay, so now we want to convert from degrees to radians. So let's say we want to convert 180 degrees to radians. Okay, so this is it. We define a variable that stores our angle, and then most importantly, we call this function math.radians easily. That is what converts this to radian. So you see, and that is because 180 degrees is just pi in terms of radian. And if you can convert from radians to degrees, so let's say we want to convert pi over 2 to degrees. Again, simple. You use m.degrees, and this is it. Simple. And you can even define infinity. Okay, so if you want to just say m.inf, you see. Cool. Simple. Okay, so now let's go to trigonometry. Okay, and just as in the case of pi, you can get sine, cosine, tangent, all your trigonometric functions are in in the map module as well. So let's say we want to show that sine square x plus cos square x is equal to 1. That's a popular trigonometric identity. So, and that's very easy to do. Okay, so you can actually show this using any value of x, because that's virtually what the identity is saying. So let's say in this case we want to use 30 degrees, okay, which is pi over, pi over 6, okay. So again, if we want to use pi, we always have to say m dot pi. So this gives us the value of pi over 6, and that's our x, okay. And all we need to do is just replicate this expression. See, m, so now we want to use sine, so we say m dot sine x, okay. And as you learned earlier, squared, this gives us exponents. So this is just x squared, and this is sine x squared, this is cos x squared. And let's see, so 1, so this is it, so that's correct, okay. Now let's do something a little more interesting. So let's say we want to plot this graph, okay. We want to plot the function y is equal to 1 plus sine square x in the range minus 2 pi to 2 pi, okay. And if you want to plot, there are two libraries, okay, that you need to know how to play with, okay. And okay, so first you need to import the matplotlib, the pyplot module, okay. So this is the module, okay, and we are importing it as plt, so which means this becomes our alias for this module. And you also need numpy. Now this is a really good library for arrays, okay. So these are the two libraries, or two modules or so that you need to import to plot, okay. But I'm sure we have all plotted stuff before, okay. So to plot a graph, let's say a two-dimensional graph, you need the x and, well, you need coordinates of the points, right? So which means the x and y values in this case, okay. So for the x values, this is simple because they have said in the range, so which means x lies between minus 2 pi and 2 pi, okay. So what we want to do now is we want to generate, it's up to you, you can take, but you know that the more values, the more points you generate, the smoother your curve. So we want to generate 100 values, in this case 100 points, okay, between 2 pi, minus 2 pi and 2 pi. And what the syntax for this is this. So you're using now the numpy module here because, okay, and we're using np because we imported it as np. So np, okay, but linspace. So linspace is the syntax for generating points, okay, of values in a range. Okay, so this first one is the start of the range, this is the end of the range, and this shows the number of values you want. So if you want 50 values, you just put 50. So this generates basically our x values. That's decent, okay. Now the y values, again, simple, okay. We know that y is this expression, so all we have to do is substitute x into this expression. So simple, 1 plus, okay, sine square. But now I want you to pay attention to something, okay. Here we used m dots, but here we're using np, and this is really cool. The numpy library, yeah, that's how I want to call it, okay. So the numpy library really is very good, okay. So it has most of the functions that the map module has, okay. And so which means normally we would have used m.sin x, okay? But if you use that m.sin x, you're going to get an error because we have generated this x, these x values using the Numpy library here, np. So if you put m here, then we're going to have an error. So easy, it's the same syntax, but only instead you use the Numpy here, so that there won't be any compatibility issues. So this is just sin x, this gives us sin x, and this is just sin squared, which is simple. So this part of the code generates our x and y values, okay? So now we want to plot this, okay? And again, this is simple. It makes simple. It makes sense. So if you want to plot, so we know that the alias for our module, that will help us plot is plt. So just a plt plot xy, just as we used to do. Okay, so you plot the x and y values. Okay, so this will plot the points for you. Then you want to label the axis. So this will label the axis. So this is plt x label, just gives you the label for the x axis. So you can put anything here. Plt y label gives us the label for the y axis. And this title just gives us the title of the plot. And what you see here, I think I did, when we started using Colab, I did tell you about Latex. So I'm not going to treat this, okay? You can go read about Latex, how to write equations in Latex. Because if you want the equation to show in your title nicely, in the form of an equation, then you need Latex. So these are Latex. This is just a Latex syntax for this expression, okay? And you need this one to make the plot show, especially if you're using a desktop-based IDE like Spider or PyCharm. If you don't put this, you're not going to see the plot. Okay, so here you can see the plot even without this. So let's run this now. Okay, always okay. So you need to import the things first, and now we run. So this is easy. So you see your plots, you see the labels, you see. So you see these nice equations. So I had to enter them using Latex so that you could see them, but you don't have to put them there. Okay. So I can change this one and say, and see. So that's it. So that's fine. So now let's see. Okay, another application of the math module. So power and logarithmic functions. So let's say we want to plot this lim. This is natural logarithm. So we want to plot y is equal to the natural logarithm of this expression here in the range 1 to 50. Again, okay, just to show you how to use the math module to evaluate this expression. So let's say we want to evaluate the value of y at one point, just a random point. This is just to illustrate. So you see, we have our value of x, so we want to find the value of y at this point. And again, we write this expression, which m is because we're using the math module to do that, and log. Okay, if you want natural logarithm, you just say log. Okay, that is log. That will give you natural logarithm, and we enter the expressions here. Simple. X to the power 3, this, and this is power, and this is straightforward. And so let's say we want to round our value to 2 decimal places. You see, simple. Okay, that is us. But now let's say we want to generate many values between this range and plot them. Again, as I said earlier, the first thing you do is you generate your values of x and y before you plot them. Very straightforward. So again, we use the Numpy library, linspace. So this is the lower range, upper range, and we want 100 points. And this is just our expression, which is almost the same as this. The only difference is we're using the Numpy library now because of compatibility issues. Okay, we have generated this X using this Numpy library. So that's just a difference, but every other thing remains the same. And now this is, we plot a function, but you can see that I have added a couple of, stuff here. So you can specify the color of, of your plot or your line. Here we want red. So you just say the color is equal to red. But take note, this is a keyword. It's not included in your double quotes. It's not string. So if you pass it as a string, you're going to get an error, but the value is a string. So you can either say red or you can say R alone. Okay, R stands for red here. So the line style, which means here I want dash lines instead of solid lines. Instead of the solid lines, because the solid lines are, this solid line is the default. Okay. So marker, which means, the marker at the data points is we want, plus, but mind you, there is a list of accepted markup types and line styles. Okay. But you can just go to the matplotlib page and you see all of those. Okay. And so this will format our line accordingly. Then here for the label, I've also added a couple of new stuff. You can specify the font weight if you want normal or bold. Then the font size you can specify. So it's so simple. Okay. And the same thing here. And now we can, okay, here I have only added limits. So you can see that here, the box is not tightly fitted onto the plot. So if you want the box to tightly fit onto the plot, or, to cover only a certain range, then this is how you specify. So this is, X limit. So it means X ranges from 1 to 50. Simple. So if we were to run this now, you'll see. And that's so straightforward. Okay. So if we were to change the range, let's say we want to change the range to 30. Okay, let's say 40. Okay. 40. Now you'll see, subset 40. If we were to bring, say, okay, okay, hold on for me. So let's say we want to do this to, okay, okay, 30, and maybe let's say this is 20. Okay, see, so it's only giving you within that range, so you have a lot of flexibility. Okay, so now let's, still on logarithms. So let's say we want to plot the function y is equal to log 10, log to the base 10 of this expression in the range minus 10 to 10. I know you're familiar with this now, but this is just to make it stay. So again, let's try to evaluate this expression at only one point. So let's say we want to express the value, and we want to evaluate the value of y at x equals 0. So again, 0, and we pass the expression. Okay, so you can see log 10. This is like that simple. So because this is log to the base 10, we're using log 10. Okay, and here we want e to the power x. E is just it's a mathematical constant. Okay, so if you want that, the syntax to use is exp. So we just say m.exp, and that will give us e to the power. Then we just put 2x plus 1 plus m exp, and so on. So it's so straightforward. And again, here we want to round this to small places, and see, we have our answer there. And as you can see, okay, so now let's say we want to plot this. Again, the first thing you do, you derive your x and y values. Minus 10, 10. Here we want only 50 points. You can change that. And again, you write the expression, which you know. Now, the only difference here is we're using NP instead of M, because we're using a different library now, because we generated X using this library, so we don't want any compatibility issues. And this is what we use to plot our function. Now here, you see, color, here we're just G, because we want green, and the line style now is this type, and every other thing is the same. And here you are. Perfect, easy. And there are also other functions in the math module. We have like fsum, which you use to sum all the values in a list. So let's say this list, and we want to find the sum of the values there. So this gives you, in fact, for Python version 3.8, you can use products like m.prod will give you the product of all these values, but that's not in this version. Then let's say we want the square root. So let's say, this value we got here 15, we want the square root of this. So it's m.sqrt, that's the syntax for square root, and 3.87. Let's say we want factorial, say 5 factorial, just m dot, this is actually long, you write the full factorial, and good. So simple and straightforward. So that's about everything we have for today. For further reading, which I recommend you do, so if you want to know more about the Matplotlib library, just go to this place, and this is the official page, and there are a lot of nice things for you to learn from. And if you want to learn more about the Numpy library, you come here, see, for absolute beginners, so you can play around with this, and it should get you up to speed. And I have 2 exercises for you to try at home. I really advise you try most of these exercises, because I have carefully planned them to challenge you. Okay, and programming, you can come here, sit and listen, and everything makes sense to you, but trust me, if you don't practice, you forget everything. So the first problem for you to do at home is you write a program to find the roots of a quadratic equation and plot the graph of the equation. And the second one is, this is for electrical engineers, but you don't need to be an electrical engineer to answer this, because I have explained everything. We have parallel and series circuit. So for a parallel circuit, so let's say you have n resistors in a parallel circuit. So you can deduce the total resistance, so the effective resistance of that circuit, from this expression. Okay, so this is the expression: 1 over R, which is your total resistance, is equal to the sum of the reciprocal of the resistances of the resistors. Okay, so I want you to write a program that will calculate the resistance of a circuit of 5 resistors, of a parallel circuit of 5 resistors. So I think that is all